Okay, let's dive deep into something absolutely fundamental to life. Water.
Hmm.
It's everywhere. The universal solvent, totally critical for, well, everything biological.
Yeah, nutrient transport, pH balance.
Keeps our cells running smoothly. Seems simple enough, right?
It really does. Just HO, you think. But the sources we've looked at show the science is really exploding. It's moving beyond just, cleaning water
Right.
to exploring these really novel properties. They often get called alive waters.
Alive waters. That sounds interesting. So our mission today then is to take this pile of sources and really pull out the key nuggets.
Yeah.
What are the blueprints for building these next generation water systems? What's the science behind it, both the stuff we know and the really cutting edge ideas?
And who are the people pushing this? The pioneers trying to optimize water for our actual health.
Exactly. We need to explore the practical side, the system designs, and also dig into the scientific concepts. How could water be made alive? Could it really enhance cellular energy? That kind of thing.
It's a fascinating area.
Okay, let's start right at the beginning then. In our bodies, water is clearly, well, it's more than just two hydrogens and an oxygen molecule floating around.
Oh, absolutely, so much more. You should think of it as the fundamental matrix of life itself.
Right.
It's completely indispensable for cellular metabolism, how our cells actually make and use energy, specifically ATP production.
ATP, that's the body's energy currency, isn't it? And vital for mitochondrial function, the cell's powerhouses.
Exactly. And we know that problems with mitochondria dysfunction, it's linked to so many chronic diseases.
Hmm.
So keeping those powerhouses healthy is, well, it's a major health goal. And this is where the standard picture of water starts to get really interesting. And sometimes, frankly, a bit unconventional.
How so?
Well, you start hearing concepts like structured water or clustered water, anomalous water, even this idea of a fourth phase of water.
Okay, so these theories are suggesting water can exist in different, like, stable arrangements, not just liquid, solid, gas.
That's the core idea.
Yeah.
And the proponents, they suggest these structures have unique properties, maybe even health benefits.
Right.
And what's really fascinating, you look at the sources, you see different theorists coming at it from different angles. People like Ma Wan Ho or Shuyan Lo are mentioned implicitly. They might call it stable water clusters or coherent domains, but they're kind of converging on this idea of structured water as a physical basis.
Hmm.
Maybe it explains complex biological stuff or effects seen in alternative health.
Interesting. So, if we want to engineer water for health, nature seems like the obvious place to look for inspiration, doesn't it?
It absolutely is. I mean, people have sought out natural waters with unique properties for healing for, well, centuries.
Like traditional mineral springs.
Exactly. Those dissolved minerals, gases,
Yeah.
they were historically linked to therapeutic benefits.
And the sources we have highlight some really remarkable examples. Tell us about Hunza water. That name comes up a lot.
Ah, yes. Hunza water, from that sort of legendary valley in the Himalayas. It's described as having these really fascinating properties, like
Yeah.
it contains ultrafine particles, colloidal and nanocolloidal silica.
Nanoparticles of silica, and the idea is these tiny particles act like little templates.
That's the theory, yeah, that they help structure the water molecules around them.
Okay.
And this proposed structuring is linked to a really low surface tension, reportedly around 58 dynes per centimeter.
Mhm.
Compare that to like 72 to 78 for regular water.
And lower surface tension. That means it moves across cell membranes more easily,
Uh,
theoretically.
that's the idea. Better nutrient delivery, better waste removal, maybe.
It's also noted for having a high concentration of anionic hydrogen, giving it strong antioxidant
Yes,
properties.
exactly. This shows up in its RH value. That's a measure of redox potential, basically antioxidant power.
Right.
Hunza water is reportedly 1820, which is exceptionally low, meaning high antioxidant capacity. Healthy blood in, say, young athletes is maybe 21.5 to 23.5 RH.
Wow.
So this high antioxidant level is really central to the longevity claims you hear about the Hunza region. There are even commercial products, like Microhydrin mentioned in the sources, trying to copy this, claiming RH values down to like 1.3.
Okay. Then there's Nordna water from Germany. What's the story there?
This one's often called natural alkaline reduced water or natural hydrogen water. And there are studies cited reporting specific benefits.
Like what?
Well, one observational study saw pretty significant improvements in blood glucose, HbA1c, that's your long-term blood sugar marker,
Yeah.
cholesterol, and serum creatinine in about 45% of type 2 diabetes patients who drank it.
45%. That's a striking number. Were there cognitive effects mentioned too?
Yeah, a randomized controlled trial in older adults suggested improvements in cognitive function, specifically attention and short-term memory.
Interesting.
It also reportedly has a high negative ORP, another measure of antioxidant potential. Negative is good, means more antioxidant power. And proponents also claim it has like smaller molecular clusters and shows some insulin-like activity.
So Hunza and Nordernau, they seem to have these measurable properties, the low RH, negative ORP, specific minerals linked to claimed benefits. But then Lourdes water in France, that presents a really interesting contrast, doesn't it?
It absolutely does, because when you look at the standard scientific analysis,
Mm-hmm.
it's clean water, sure. It has common minerals.
Right.
But, and this is crucial, it lacks any unique or special mineral properties.
Really? So chemically, it's pretty ordinary.
Yeah, it's described as quite pure and inert from a chemical standpoint.
Yeah, it's tied to this deep tradition and well-documented, church-verified miraculous cures.
And this contrast is key. It's highlighted in the sources. You compare Hunza and Nordernau, measurable chemistry, linked to effects, with Lourdes' ordinary chemistry, but profound perceived impact.
So what does that suggest?
Well, it suggests the healing aspect might involve something beyond just the chemical composition we can easily measure. It kind of points back towards those structured water ideas, or maybe biophysical energetic influences.
Hmm.
It really makes you wonder, are there effects happening that our standard chemistry toolkit just isn't catching?
That's a really good point, and a perfect bridge from observing nature to trying to engineer these properties ourselves. How do we actually take these ideas and build the next generation of water systems? The sources lay out 3 conceptual blueprints, kind of scaling up in cost and complexity, apparently based on AI input.
Right. They start with a conceptual low-cost system. Estimated component cost around $2,000, maybe $1,500 total cost build.
And this one focuses on the basics, right? Foundational purity.
Yeah, pretty much.
Yeah.
Basic filtration, maybe distillation, then remineralization, some basic H electrolysis to add hydrogen, and UV sterilization for safety.
Okay, then the mid-range system. That jumps up to around $5,000 components, maybe $4,000 total.
Yeah, and it enhances things. You get more advanced distillation, like low-temperature vacuum distillation,
Right.
better remineralization,
Yeah.
more robust electrolysis for both H and O.
And it introduces something new, sound.
Basic sound or frequency infusion, yeah. Plus the UV sterilization again.
And then there's the ultimate system. This sounds like the full bells and whistles version. Estimated components, $32,700.
That's the number given, yeah. And this one integrates pretty much all the advanced tech mentioned in the sources.
Such as?
Okay, you've got hybrid solar distillation water electrolysis, the HSDWE tech, advanced remineralization, high power H and OA electrolysis, advanced sound and frequency stuff,
Hmm.
scalar energy infusion, UV sterilization, of course,
Wow.
plus a really key component, an AI-driven personalization module, and an advanced delivery system for nutrients.
And the sources even break down costs for this one, like $10 for the HSDWE, $5 K for advanced electrolysis, $2 for the AI module.
Yeah, they give those specific ballpark figures for the modules.
Okay, let's unpack some of these core technologies then. Purification is always step one, right?
Absolutely fundamental. You know, conventional reverse osmosis, RO, it's really effective at removing contaminants. It gets rid of up to 99% of heavy metals, PFAS, those nasty forever chemicals,
Okay. Yeah.
other chemicals. It does a good job cleaning the water.
But you often hear people call RO water dead water. What's that about?
Well, it's a common term in the health water space, though scientifically water isn't really alive or dead.
Okay.
The idea comes from the fact that RO removes pretty much everything, including beneficial minerals, and it can leave the water slightly acidic.
And that's seen as a negative.
By many consumers, yes. Whether it's scientifically a major health issue is debated, but it's a big perception thing. And it really highlights why remineralization after purification is considered so important in these systems.
The sources mention next generation distillation as maybe an improvement over RO in some ways.
Yeah, traditional distillation has drawbacks. It can be slow, uses a lot of energy, removes minerals like RO, and sometimes volatile organic compounds, VOCs, can actually carry over with the steam.
Okay.
But newer methods like low-temperature vacuum distillation are more energy efficient and better at keeping those VOCs out. They're also good for PFAS removal.
And that hybrid solar distillation water electrolysis, the HSDWE, that sounds pretty revolutionary.
It's really fascinating tech mentioned as coming out of Cornell. It uses solar power, even waste heat from solar panels, to do 2 things at once.
What are they?
It produces green hydrogen, which is huge for sustainable energy.
Right.
and highly pure drinking water, even from seawater. So it tackles energy and water scarcity sustainably. It's pretty cool.
Very cool. And after you've got this super pure water, remineralization is absolutely key.
Absolutely critical, yeah.
Yeah.
You've stripped everything out. Now you need to put the good stuff back in. Essential minerals like calcium, magnesium,
This is all
potassium.
about trace elements, too.
Yeah, the sources mention systems adding up to 18 different trace materials. This does a few things. It stabilizes the pH, ideally aiming for that slightly alkaline range, maybe pH 8 to 9.5.
Makes sense.
It also massively improves the taste, which is important. And it enhances the water's bioavailability, making it more living, like those natural springs people seek out.
Okay, moving from basic chemistry to dissolved gases. Electrolysis comes up a lot for controlling hydrogen and oxygen. Molecular hydrogen, H0, seems like a really big focus.
H is definitely a hot area in research right now. It's known as a potent antioxidant, but importantly, it's selective.
What does selective mean here?
It means it targets the really nasty free radicals, like hydroxyl radicals and peroxynitrite, without messing up the beneficial signaling molecules our body actually needs for normal function.
Ah, okay. And it seems to specifically help out the mitochondria, those cellular powerhouses we mentioned earlier.
Yes, the research suggests it really supports mitochondrial function. It might even boost ATP production, that energy currency.
How?
While some theories propose it might contribute electrons or protons directly into the mitochondrial respiratory chain, the energy production line. Plus, it's tiny. HERS is the smallest molecule, so it can easily get inside cells, even into the mitochondria and the nucleus, offering protection right where it's needed most.
And beyond the antioxidant and energy stuff, it's linked to like performance and anti-aging.
That's what studies are suggesting, yeah. Potential benefits for athletic performance, helping clear lactate, maybe improving endurance, helping with alcohol metabolism, and generally supporting processes linked to aging well.
And electrolysis is a common way to make this.
One of the most common ways to dissolve hydrogen gas into water for drinking, yes.
Okay, what about the other side of electrolysis, optimizing dissolved oxygen?
Well, oxygen is obviously vital for cellular respiration, breathing, basically. Proponents of oxygenated water claim that increasing the dissolved oxygen you drink can help with athletic performance, metabolism, maybe cognitive function.
But there's a catch. The sources seem a bit cautious here.
Yeah, the sources rightly note that absorbing extra oxygen through your stomach isn't nearly as efficient as breathing it into your lungs.
Our guts aren't lungs.
Pretty much. The digestive system isn't really designed for primary oxygen uptake. However, there's this interesting concept introduced called singlet oxygen energy, SOE.
Singlet oxygen energy, what's that?
It's less about just jamming more oxygen molecules into the water and more about the energy that's released when oxygen shifts from a highly reactive, excited state, the singlet state, back down to its normal ground state.
So it's about the energy signature of the oxygen, not just the quantity.
Exactly. It's a different way of thinking about it. There are studies mentioned using devices designed to generate SOE, often inhaled, that showed benefits like reduced energy consumption during exercise, better running efficiency. So the goal becomes maybe smarter oxygen delivery, potentially influencing how the body uses the oxygen it already gets from breathing.
And nanobubbles are important for keeping both the hydrogen and oxygen in the water longer.
Absolutely crucial for stability, yeah. Nanobubbles are incredibly tiny gas bubbles, thousands of times smaller than regular ones.
And they don't just float away.
That's the magic. Because they're so small and have unique surface properties, they can stay suspended in water for days, weeks, maybe even longer.
So they keep the H and O rows dissolved.
Exactly. It keeps those beneficial gases in the water for much longer, meaning you actually have a chance to consume them, increasing their bioavailability.
Okay. And electrolysis also produces something called electrolyzed reduced water, or ERW. Is that just hydrogen water?
It's more than just hydrogen water, though HE is a key component. ERW is the water produced by the electrolysis process, and it's often seen as having synergistic benefits.
Like what?
Well, it typically has an alkaline pH, which proponents say helps neutralize body acidity, maybe reduce inflammation. It definitely has general antioxidant properties from the AGRO and potentially other factors. And some claim improved hydration due to smaller water clusters, although that's a debated point scientifically. There's also research suggesting it can positively modulate gut microbiota, help the good bacteria, and offer broader cellular protection, like protecting DNA or supporting pancreatic cell health.
Right. Now we're moving into territory that feels a bit more cutting edge, maybe more speculative. Energetic water infusion.
Hmm.
Let's start with sound and frequency infusion. That sounds wild.
Is a fascinating concept, yeah. It's based on this idea that our organs, our cells, they all vibrate at specific frequencies.
Okay.
And practices like voice spectral analysis, which builds on work by people like Kay Thompson Liu and Alfred Tomatis, they try to analyze your voice to find missing notes or frequencies that are thought to correspond to imbalances in the body.
And the idea is to put those frequencies back using
Ah,
water.
that's the general concept. Reintroduce those frequencies, maybe by infusing them to water using sound. Now, the science does show that sound definitely affects water structure.
Really? How?
Yeah, studies using a technique called aquaphotomics have shown that different sound frequencies, like the classic 432 hertz versus 440 hertz debate, can cause distinct structural changes in water. It affects the hydrogen bonding, the stability, how the molecules are organized. Frequency-specific effects have been observed.
So sound definitely impacts water structure. That's established.
At a basic physical level, yes. The leap,
Quick
however,
leap.
the leap from seeing those structural changes in a lab beaker to claiming specific therapeutic outcomes in a person based on their voice analysis and drinking water infused with those frequencies,
No.
well, that currently lacks robust, large-scale clinical validation in mainstream science.
Gotcha.
And it definitely touches on more controversial ideas, sometimes getting linked to concepts like water memory.
Right. And then there are scalar energies, sometimes called Tesla waves. This sounds even more out there, and it's definitely debated.
It is a very debated topic, yes. Scalar waves, or scalar energy, are described as these non-electrical, sort of enigmatic energy fields.
Okay.
Proponents claim they can do things like restructure water by aligning the water dipoles, the little positive and negative ends of the molecule.
Yeah.
They also claim benefits like enhancing cellular resonance and communication, stimulating mitochondria, reducing inflammation, boosting immunity, even helping mental well-being.
But where does this stand scientifically? Is this accepted physics?
It's really important to be clear here. The mainstream scientific community is largely divided, maybe skeptical is a better word, about the existence and efficacy of scalar energy as it's described in these health contexts.
So it's outside standard physics and biology.
Pretty much, as they're currently understood. It's a concept that requires a lot more rigorous, reproducible research before it could gain wider acceptance. It's definitely one of the more speculative components you see mentioned in these ultimate system blueprints.
Okay, so it's really clear we're seeing this blend. Established science purification, hydrogen benefits mixed with concepts that are emerging, and some that are, frankly, highly debated. Speaking of pushing boundaries, who are some of the key innovators the sources highlight in this space?
Yes, several interesting pioneers are mentioned. Eric Laraker, he's a holistic veterinarian who's apparently spent over 30 years researching water, light, frequencies, quantum physics type stuff.
And he developed a specific water.
Yes, Analemma water. It's described as full-spectrum, coherent water. Apparently, it's made using this year-long process involving sunlight, natural elements, and it's claimed to be stable, holding its structure for months.
What kind of results are claimed? Any studies?
The research cited is pretty impressive. Things like an 80% increase in biophoton emission that's like light energy from tomato cells treated with the water.
Wow. What about humans?
Human studies are cited too, some apparently double-blind and placebo-controlled. They reported biological age reversal based on glycan-age testing up to 12 years younger in just months.
12 years. Seriously.
That's the claim. Also, a significant increase in ATP production, around 27%, and improvements in gut dysbiosis scores by over 10%. And applications in animal and plant health too, like making plants more drought resilient.
Okay.
Yeah.
Who else? Robert Slonak is mentioned as a major water expert.
Yeah, he's a real veteran.
Yeah.
A pioneer. He was involved way back in the 70s bringing reverse osmosis tech to the public.
Yeah.
But he later shifted his focus to more advanced concepts. Became a big champion of molecular hydrogen, co-developed one of the first reactive H-Euro tablets. He's also involved with deuterium-depleted water, DDW, and things like marine plasma quitin. Is a brand mentioned which mimics blood plasma's mineral balance to restore the body's bioterrain.
Then there's Max Langenberg, over 40 years in water research.
Right. His focus is described as quantum biohydrodynamics. He developed Langenberg oxygen water. It's engineered for extreme purity, balanced minerals, and specifically aims to minimize water cluster size, trying to get it towards a monomolecular state like single water molecules.
Single molecules.
Oh.
And it contains special oxygen and elements.
Reportedly, yes. Stable monoatomic forms of oxygen and also monoatomic platinum group elements.
And the claims for this water are pretty big.
They are significant, yeah.
No.
Things like accelerated metabolism and reaction times. Enhanced neural ability described almost like making neurons into a superconducting antenna, boosting brain and immune function, partly attributed to those platinum group elements.
Mm.
And his work apparently also extends to large-scale stuff like waste-to-energy technology, using similar principles to convert waste into power, water, and fuel.
Fascinating link. Okay, finally, Dick Willert, a materials scientist.
Yes. His focus is on functional water made via electrolysis. He developed technologies called WET, Water Enhancement Technologies, and IP Water, where IP stands for ion product.
Ion product.
Yeah, his water aims for high energy content, a neutral pH, but optimized for this specific measure, the ion product. He patented a hydration machine that's claimed to produce water with higher energy and double the dissolved H and O heroes compared to standard electrolysis.
And are there studies on its effects?
Improved cellular hydration is reported for his technology, yeah. And it apparently has significant uses in agriculture, too, reducing pathogen and pesticide use by strengthening plants, increasing yield.
So broad applications.
Very diverse potential uses mentioned. Bottled water, aquaceuticals, disinfectants, cosmetics, even a process for non-barrel aging of alcohol.
These innovators are definitely working on some interesting fringe-pushing stuff, and the sources briefly touch on even more cutting-edge concepts for biooptimization.
Right. Just quick mentions, things like exploring magnetically structured water using magnetic fields to potentially influence water's hydrogen bonding and structure.
Okay.
Terahertz, radiation. That looks at tuning water vibrations to frequencies that might resonate with our cells or biomolecules. Biophoton emission and coherence enhancement, using light itself to maybe enhance water's own light energy or coherence. And harmonic resonance cavities, using specific geometric shapes and materials to create resonant fields that could, theoretically, imprint the water somehow.
These concepts really seem to push towards that bioinformational view of water we touched on.
Exactly, where water isn't just a passive solvent, but might actively carry or transfer energy and information relevant to biology.
Okay, let's bring this back to that ultimate system blueprint. How does all this potentially connect to you, the listener, personally? That AI-driven personalization module sounds pretty central.
It really does seem like the linchpin for making it truly individual. The idea is this module uses artificial intelligence to analyze your real-time biological data.
Like from my fitness tracker or genetic tests.
Yeah, think data from wearables, maybe genetics, microbiome analysis is mentioned, potentially even things like voice analysis patterns.
Yeah.
Based on this constantly updated picture of your specific health status,
Uh-huh.
the AI could dynamically adjust all the water parameters.
So the water I drink in the morning could be different from the afternoon based on my stress levels or activity. Truly personalized water.
That's exactly the vision. The AI could fine-tune the mineral mix, change the concentration of H and O euros, select specific frequency patterns, adjust the scalar field intensity, maybe even dispense specific micronutrients encapsulated within the water.
Wow.
The goal is water tailored precisely to your unique and changing needs, maybe even moment by moment.
And the sources list a whole bunch of benefits for this AI part.
Yeah, beyond the potential direct health benefits for you, the user, it's framed as enhancing the whole user experience, making people more engaged,
Right.
which could lead to better health outcomes because it adapts to individual differences. Plus, it generates huge amounts of data, giving insights into which water parameters work best for whom, helping to refine the whole technology over time.
And that micronutrient delivery part uses liposomal or nanoencapsulation. What's that for?
Correct. That's a delivery technology. It's a way to package specific nutrients, vitamins, antioxidants, whatever, inside tiny protective bubbles, either liposomes, fat-based, or other nanoparticles,
Why?
to ensure they get delivered effectively where they need to go in the body, making them more bioavailable, easier for your body to absorb and use. And it does this without messing up the carefully engineered purity or structure of the water itself. The capsule protects the nutrient.
So when you look at the whole integrated design, especially that ultimate system, it really feels less like just a fancy water filter and more like a health engineering platform.
It really does. The different modules are designed to work together synergistically.
How so?
Well, you start with that foundation, purity and biocompatibility. That comes from the advanced distillation, maybe the HSDWE, plus the careful remineralization. That gives you this pristine, mineral-balanced, pH-optimized base, like the best natural spring water imaginable.
Okay. Layer one.
Then layer 2, targeted molecular enhancement. That's the precision electrolysis, adding optimal levels of H and O rows stabilized by nanobubbles, creating that electrolyzed reduced water. This layer's aimed squarely at cellular energy, antioxidant defense, maybe better hydration, gut health support.
Got it. Layer 3.
Layer 3 is the energetic and informational infusion. That's where the sound, frequencies, scalar fields, maybe those other cutting-edge techs come in. This layer is trying to influence the water's structure, its resonance, its energetic properties, potentially interacting with your body's own biofields in subtle ways.
And layer 4 is the brain.
Layer 4 is the AI-driven personalization, the intelligence that dynamically adjusts all the other layers based on you, your real-time biological feedback.
Okay. And the overall goal of stacking all this together is?
The overall goal is to promote what proponents sometimes call overall structured water, or maybe an EZ-like state, referring to exclusion zone water within your body's cells. The theory is this improves fundamental cellular processes: hydration, nutrient absorption, waste removal.
It's a pretty bold vision. And like you said, it blends stuff that's scientifically solid with concepts that are, well, still emerging, and some that face really significant scientific questions.
It absolutely is bold, and the sources do acknowledge this tension. They emphasize that the proposed modular design is key. It lets you add or swap out technologies as future research hopefully validates them.
Adaptable.
Yeah, exactly. It really represents a shift in thinking. From just trying to copy nature's best water to actively trying to bio-optimize water, moving towards that bioinformational model where water might carry more than just chemicals.
Which brings us, inevitably, to the scientific skepticism. This is a big hurdle for many of these ideas, isn't it?
A major hurdle, yes. And it's important to address it directly. While some specific studies get cited, like those double-blind, placebo-controlled trials on analemma water looking at ATP, glycanage, the microbiome,
Right.
the sources themselves acknowledge that for many of the broader claims about structured water, there's a real lack of large-scale, independently replicated, peer-reviewed studies published in mainstream scientific journals.
Why is that? What are the core challenges holding back wider acceptance?
There are several key things. First, there's often a lack of clear, universally accepted definitions. What exactly is structured water? How do you measure it consistently?
No point.
Different researchers might use different methods, making it hard to compare results. And then there's a fundamental debate in physical chemistry,
About whether it can even exist.
kind of, about whether stable, long-lasting structures can really exist in liquid water. Hydrogen bonds are constantly breaking and reforming incredibly fast. We're talking less than 200 femtoseconds. So the idea of a persistent structure is challenging for many chemists.
And that whole historical controversy around water memory probably doesn't help either.
It definitely casts a long shadow, yeah. The idea that water can retain information from substances previously dissolved in it, well, it's widely considered pseudoscience by the mainstream,
Why?
mainly because key experiments couldn't be replicated independently, and it just doesn't fit with our established understanding of physics and chemistry. So that history makes the scientific community extra cautious, maybe even skeptical, about any concept suggesting water holds information beyond its simple chemical makeup.
It also seems like there's often a mechanism gap, right? Even if you see a positive biological effect in a study, knowing how it happened can be tricky.
Exactly. That's a huge issue. You might see, for instance, that cells grow better in certain treated water. But the underlying mechanism, how exactly did the water structure or frequency infusion cause that specific cellular change, is often unknown, or based on theories that aren't yet widely accepted or proven.
So the need is for more rigor.
Absolutely. The sources really underscore the need for rigorous scientific inquiry. That means meticulously designed experiments, proper controls, methods that other labs can replicate easily, transparency in reporting, being aware of biases, and using robust statistical analysis.
Okay, given all this complexity, the debates, the need for rigor, is there anything that could help? Any tools to maybe bridge these gaps or speed up the research?
Well, the sources introduce one potential tool, Dr. Shiva Ayadurai's CytoSolve platform. It's positioned as a computational approach that might help.
CytoSolve, what is that exactly?
It's a computational systems biology platform. Its main trick, apparently, is that it can integrate lots of different molecular pathway models, complex computer simulations of how biological processes work, without needing to actually merge the underlying computer code for each model.
Okay.
And it can run these complex combined simulations in parallel across many computers.
So how could that specifically help with researching alive waters?
Well, you could potentially use it to model these really complex interactions between different types of water and biological systems, all inside the computer.
Like simulating how structured water might affect ATP production.
Exactly. Or simulating hypothesized mechanisms. How might a certain frequency affect a cell membrane? How might ERW impact specific gut bacteria populations? You could build computational models of these ideas.
So you could test theories virtually before doing lab work.
Precisely. It could help generate really specific, testable hypotheses that you could then take to the lab. Maybe predict biological outcomes computationally first. It could potentially help optimize water parameters, which combination of factors might be most effective, based on simulation results.
And help connect the dots between molecular changes and bigger effects.
Yeah, potentially helping bridge that micro to macro scale link.
Yeah.
How do molecular level water structure changes actually influence cellular behavior? Or even whole system effects? It's presented as a tool that could accelerate R&D and maybe even push for more rigor by forcing researchers to define their proposed mechanisms precisely enough to build a computational model.
Interesting potential. So, looking ahead, what's the path forward recommended in the sources? How does this field mature?
The key recommendations seem to boil down to a few main points. First, collaboration. Establishing interdisciplinary research consortia, getting physicists, chemists, biologists, engineers all talking and working together.
Makes sense.
Second, leveraging computational tools like Cytosol for simulation, prediction, and optimization, really using modeling to guide experiments.
Okay.
Third, standardization. Developing standardized characterization methods and biomarkers. We need agreed-upon ways to measure these alive water properties and their biological effects consistently so results are comparable. And fourth, clinical validation. Conducting long-term, independent clinical trials. Ultimately, we need conclusive data on whether these approaches are truly effective and safe for humans. And of course, ethical considerations and responsible innovation are woven throughout.
Wow. This has been a really remarkable deep dive. We've gone from water as just, basic HO, essential but simple,
Right.
all the way to this incredibly ambitious vision of engineering alive water systems, personalized down to the individual cell level for optimal health.
It really shows a field that's, well, it's very much in flux. You've got this fascinating blend of established solid technologies right alongside concepts that are still pretty speculative, but potentially revolutionary if they pan out.
Yeah, and it starkly highlights the huge scientific challenges, the skepticism these frontier ideas face, but also, the potential rewards if rigorous research can actually bridge those gaps in understanding and validation.
Absolutely. It really underscores how much we might still have to learn about something we interact with every single second, something as seemingly simple and ubiquitous as water.
It really makes you think, doesn't it? That water, the stuff that's fundamental to every single living thing on this planet, might hold secrets about health, about energy, maybe even about biological communication. Secrets that our current science is only just beginning to scratch the surface of. It feels like it's blurring the lines between physics, chemistry, biology in ways that are both incredibly challenging, but also, well, pretty exciting. Definitely
Lot,
something to ponder next time you raise a glass.